which will helpful to Iit-Jee and Neet competitive exams. First important trend, basic strength. When magnesium oxide, strontium oxide, potassium oxide, cesium oxide, comparison about basic strength, which is more base and which is less base. Always the basic strength depends upon electropositive nature. When electropositive nature increases, basic strength increases. In this case, the cesium is the larger atomic size, hence the basic strength is increased. Magnesium is smaller atomic size, hence it have a lower basic strength. One important point you have to observe in this case, magnesium is belong to second A group and potassium is belong to first A group. When you go to the first A group and second A group element, how to analyze the atomic size of these elements? In this case, I am going to give you a wonderful trick to remember the atomic sizes while comparing with alkali and alkaline earth metals. Very simple, my dear students. Just you have to go through this pattern, M followed by N, M and N. Mn indicates increasing in the atomic sizes. I am showing you the lower atomic size is what here? Beryllium is the smaller atomic size as per the pattern. See here, from left to right in any period, the atomic sizes decreases. Lithium is smaller atom, larger atom than the beryllium. Hence, the atomic size starts from beryllium. Beryllium is smaller atom than the lithium. Atomic sizes decreases. It is smaller atom than the lithium. Beryllium is less than lithium. Lithium is less than magnesium. Magnesium is less than sodium. Sodium is less than calcium. Calcium is less than strontium. Strontium is less than barium. Barium is less than radium. And after starts from radium is less than potassium. Potassium is less than rubidium. Rubidium is less than cesium. Cesium is less than francium. This is about the increasing of the atomic radius. Here the least atomic radius element is beryllium. Higher atomic radius is cesium. Francium is the radioactive element. Okay. When atomic radius increases, electropositivity increases, basic strength increases. Cesium oxide is more basic. As per the given question, here the four elements are there. The first element is cesium. The second element is potassium. Where is potassium? Here the potassium. And third element is strontium. See here, strontium. And then magnesium. Now you have to write the order. Cesium is bigger atom among these four. Then cesium after what will come? Potassium is coming. Potassium after strontium is coming. And strontium after magnesium is coming. So whatever the elements they have given in the exam, you should follow this pattern. So now magnesium oxide is lower basic strength because of smaller atomic size, then strontium oxide, then potassium oxide, and after that cesium oxide. This is about the basic strength. So see here, the basic strength is directly proportional to what ma? Atomic size. Second one, what I am saying is ionization energy. Ionization energy is always inversely proportional to the atomic size. When atomic size increases, ionization energy decreases. See here, this is the bigger atom, it having lower ionization energy. And what is the order of ionization energy among these two groups? So which is having high ionization energy, my dear students? So beryllium is having high ionization energy. Then what? Lithium. Lithium is high ionization energy than magnesium. Observe, my dear students, here the smaller atom, here I have keep less than, here I am keeping greater than. Then magnesium is greater than, what will come? Sodium. Sodium is greater than calcium. Calcium is greater than strontium. Strontium is greater than barium. Barium is greater than radium. Radium is greater than potassium. Potassium is greater than rubidium. Rubidium is greater than cesium. Cesium is greater than francium. This is about the order of ionization energy. Okay, atomic size is increasing, ionization energy is decreasing. Okay, next pattern. Ionic radius. Ionic radius is entirely different from atomic radius. Now, I will show you one example. When you take a lithium atomic number is 3, electronic configuration 1s2 to s1. So this lithium atom is having two shells. This is the first shell and this is second shell. It means first shell having 2 electrons, second shell contains 1 electron. Yes, I am drawing 2 electrons and 1 electron. This is about lithium. When you want to draw the lithium ion, this is the lithium atom having 3 electrons. When you remove 1 electron from the lithium changed into lithium plus ion. Now it is having only 2 electrons. 2 electrons means its electronic configuration is 1s2. So that it is having only one shell. This one shell contains only 2 electrons. That is the difference between lithium atom and lithium ion. Always lithium ion is smaller than its parental atom lithium. Lithium is having 2 shells. Lithium ion is having only one shell. That is the reason I am especially explaining about the ionic radius. In this ionic radius also, comparative study we are seeing not only one group, both the groups you are mixing. When you mix both the groups, which is having less ionic radius and which is having high ionic radius, that we will see. This is about the first year group elements, lithium ion to cesium ion, lithium, sodium, potassium, rubidium and cesium. Then coming to the second group ions, beryllium ion, magnesium ion, calcium, strontium and barium, all are existing in the +2 state. Remember, my dear students, one more pattern I am going to show you. The same pattern is coming, M is followed by N. With a small change, first you have to come one straight line moving down in the second year group, this one. Straight line and then again M and N. So now write the ionic radius in this given pattern. Show on the screen here, Be +2 starts with beryllium and straight line next to magnesium, Mg +2, then lithium. After that calcium, sodium, strontium, next barium, potassium, rubidium, cesium. This is about the ionic order radius. Whatever the elements given in the MCQs, you have to first draw the pattern, then you can go for the perfect order. Hydrated radius. Always ionic radius is directly proportional to the hydrated radius. The smaller atom is having high hydration energy. Smaller atom means what here? Beryllium. Beryllium is having high hydration energy. Why? I am going to show you. Beryllium is a smaller atom, right? Its ionic radius is small. Beryllium ion. This beryllium ion, due to the smaller atomic radius, nuclear attraction force is high. Because of that, it attracts more number of water molecules. More number of water molecules. It holds more number of water molecules. Hence, its atomic radius should be increases in the water. Without water, it is small. With water, its atomic radius is high. When you go for the cesium, this is the cesium. Cesium atom is a bigger atom. This is the nucleus. Because of big size, it holds less number of water molecules. Less number of water molecules. Hence, in the water, cesium radius is less. Cesium ion radius in the water is less. Radius is less. But Beryllium ion in the water, its radius is high. That is the reason from beryllium to cesium, when you move in the water, which is having smaller radius, cesium is having smaller radius. Which is having bigger radius, beryllium is having bigger radius. That is the reason this is about the ionic radius without water. With water, what is the hydrated radius? I am going to show you. See here. Here less than, here greater than. This important point you are going to observe: ionic radius without water, ionic radius with water. This is about the comparative study of alkali and alkaline earth metals. The second one is ionic radius. Now coming to the third, ionic nature in water. That only I explained you. Cesium is having high, lithium, comparing with cesium, lithium is having high hydration radius or high hydration enthalpy. Because of smaller atomic size, it is showing high hydration enthalpy. This is not comparative study in this case. This is only absolutely belong to 1A group elements. Before that I explain you comparative study. This is in 1A group elements, ionic radius in water. Water in 1A group elements, lithium is having high. While comparison, beryllium will get high. Molar conductivity. Higher the size atomic element, higher the ionic radius element will exhibit higher molar conductivity because it releases electrons easily, hence the conductivity is high. Reactivity with water. The chemical reactivity is always depends upon the atomic size. In any group, when you go down or when you move from left to right in any period, when the atomic size increases, the chemical reactivity increases. Atomic size increases means ionization potential decreases, chemical reactivity increases. Reactivity with hydrogen. So which will element can react easily with hydrogen? Which element can not react with hydrogen easily means lithium hydride can holds the lithium atom can holds the hydrogen easily because of its smaller atomic size. Lithium atom is having smaller atomic size, a very small atom. This is the lithium because the hydride H minus and Li plus, the attraction force is high. While comparing with cesium, cesium atom is a large atom and then hydride is there H minus. This nucleus, the internuclear distance is high, so it is the reactivity or stability is less for this. You can divide these two components easily while comparing with these two atoms. Hence, it is more stable, more reactive. Melting point is also we can explain with the atomic size. Atomic size increases, melting point decreases. Cesium is easily volatile while comparing with the lithium. Lithium is having high melting and boiling points. Basic nature of hydroxides. Hydroxides basic nature is also depends upon the size of the atom. Size of the atom increases, basic strength increases. Size of the atom decreases, basic strength decreases. This is the order we can explain the basic strength in 1A group elements. Thermal stability. Lithium hydride is less stable than cesium hydride. Same way, the hydride stability we can explain with respect to the atomic size. Atomic size increases, thermal stability also increases. One more important point I am showing you, my dear students. Covalent character increases. Always, obviously, ionic character decreases. If there is no ionic character in that, that is less stable. Thermal stability decreases. And thermal stability is decreased. They are not stable, so you can easily boil and melt it. So melting point and boiling point decreases. These are the interlinks. Covalent character increases, ionic character decreases. When ionic character decreases, it is easily melt and boil. 10th one, covalent character lithium chloride, lithium bromide and lithium iodide. Generally we studied metal and non-metal combined with each other, you will get an ionic compound. So here lithium is metal and chloride is non-metal. So these are the ionic compounds. But the anion size increases as per Poisson rule we studied in the chemical bond chapter. When anion size increases, decrease the ionic character and increase the covalent character. Here the chlorine size when comparing with bromine size and iodine size, iodide is a larger atom, hence the covalent character is maximum in this lithium iodide. So based upon the atomic size of anion, that is iodide, we can explain this. Ionic character in case of halogens. Now here I have taken lithium, here I am taking all other elements, same element, lithium, 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 but here beryllium, magnesium, calcium, strontium and barium. So in this case, halogen is same, chloride, 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 chloride and chloride, but the alkali metal or alkaline earth metals we are changing here, beryllium, magnesium, calcium, strontium and barium. So hence the atomic size increases, cation atomic size increases, the ionic character increases. When anion size increases, covalent character increases as per Poisson rule. Solubility, which will soluble more and which will soluble less. When come to the solubility of carbonates, either alkali metal carbonates or alkaline earth metal carbonates, it is absolutely depends upon difference of radius. When beryllium carbonate to barium carbonate, the radius difference is high. How it will say? For example, here I am taking barium. Barium is a very large size atom. Carbonate is also large. So this is carbonate, CO3 minus 2, this is Ba plus 2. The internuclear distance is this. Okay, radius difference. We are comparing with the beryllium carbonate and barium carbonate. Beryllium cation is the smaller one and carbonate is the bigger one. This is the CO3 minus 2, this is Be plus 2. This is about the internuclear distance. While comparing with this and this internuclear distance is less. Okay ma, less radius. The radius difference, when radius difference increases, solubility increases. It easily you can decompose and it easily soluble in water. Solubility is high. It is difficult to soluble in water. The bond is strong. So that is the reason when metal size increases, solubility here the difference is high. Metal and carbonate difference is high, so that less soluble. Here the radius difference is small. Sorry, this is more soluble and that is less soluble. More soluble and this is less soluble. So solubility of barium carbonate is less than calcium carbonate. Calcium carbonate is less than magnesium carbonate. Magnesium carbonate is less than beryllium carbonate because of radius difference. So the barium carbonate having higher atomic size, carbonate also higher atomic size. The internuclear distance is high. Half of the internuclear distance is known as a radius. So here this is the radius. In this case, this is the radius. The radius difference is low. Hence, solubility is high. It is more soluble. It is more ionized. Solubility of beryllium fluoride to barium fluoride. In this case, the order will be different. The size of the barium increases. It means atomic radius increases. Hence, the ionization will be easy. So that's the reason it is more soluble. So what I explained in the first case, the same thing. The size of the atom increases. Here because this is barium Ba plus 2. This is fluoride F minus 2. In case of fluorides, the internuclear distance increases, solubility increases. In case of carbonates, the barium and carbonate is also covalent compound with ionic character. That is the reason when the internuclear distance increases, here the solubility decreases. In this case, internuclear distance increases, solubility increases in case of fluorides. So, compound to compound, the character will be different. Here the radius difference, here also radius difference, but the radius increases, in this case solubility increases, but in case of carbonates, radius decreases, solubility increases. In case of hydroxide, same thing, the element size increases, solubility increases. Basicity also we can explain with the size of barium atom size increases, basic strength increases. Hydration of ion, the size of the atom decreases, ionic radius decreases, hydration enthalpy increases, hydration radius also increases. Reactivity, always we can explain the reactivity with the size of the atom increases, chemical reactivity increases. Reactivity with air means oxygen. So among these alkaline earth metals, the beryllium is least reactive with oxygen comparing with the barium. Barium strontium can form peroxides and superoxides, but beryllium cannot form. Solubility, now we are seeing about solubility of sulfates. Sulfates, lower the atomic size, sulfate is having higher soluble, like carbonates. Carbonates also lower atomic size having higher solubility. In this case also lower the atomic size is having higher soluble. Melting points with respect to the halogen atom atomic size, chlorine, bromine are there here, calcium chloride, calcium bromide and calcium iodide, this one calcium iodide, CaI2 and CaF2. Here the atomic size is less. The lower the atomic size of anion will having high melting point, because the internuclear attraction is high between Ca+2 and F-. This is the more electronegative element while comparing with the bromine and iodine. Stability of hydrides, CaH and LiH. LiH is more stable because of internuclear distance is very less. Lithium atom is small and as well as hydride, the attraction force existing between these two ions is high. Thermal stability, beryllium carbonate is less than magnesium carbonate, is less than calcium carbonate, is less than barium carbonate. The thermal stability, barium carbonate is having high due to its higher atomic size. Last one, ionic character. Directly, indirectly we cover the size. With the size, ionic character increases, because higher the atomic size will give electrons easily and easily ionized. Ionic character of cesium bromide is having high while comparing with lithium bromide. So, these are the important trends in alkali and alkali.